So, hello everyone. Welcome to our this session of Open Security Summit. I'm really excited to be again here, and even more excited to hosting session that Petra and Jameel will be doing. And our session is about Sonar Cloud integration with GitHub. So enjoy the session, and I'm giving Petra the sharing and power to speak. Thank you.
Thanks for the power, Tatovic. I will use it wisely. Hello, everyone. So we'll be talking a little bit about static analysis today, me and Jameel, and our experience with Sonar Cloud integration. So, oh, 1 second. For some reason, my slides are not going. There we go. So just a quick introduction. I am a cybersecurity engineer in Glasgow. I do some medium blogging sometimes. I'm a machine learning enthusiast, worldly maps enthusiast. That's how I got my job in Glasgow. I am a medical doctor by background. I've spoken before in the Open Security Summit. I'm a fan of DevSecOps. And yeah, this is where you can find me. And also, I'm a volleyball player. I'm an athlete. So there we go. And Jameel, you want to introduce yourself?
Yeah, thanks, Petra, for giving the floor. Well, yeah, my name is Jameel. I'm basically a pointer. Pointer, like, is a term the folks uses when attacking binaries. So yeah, binaries is my game. I have a cool blog called Buffer Overflow. I do parkour besides hacking, breaking things legally and getting paid. I spoke a bit of conferences here and then. Hacking Paris, Offensive Sec, and the other folks mainly presented 0 days. And yeah, I love to analyze the source code. So that's basically me, giving you the floor.
Cool, thank you, Jameel. It's great to have you here today. All right, so I just wanted to say a little bit about from my personal experience with introducing static analysis into like a kind of DevOps pipeline, and kind of introducing it as a part of also introducing an SSDLC. So I just want to say also, anyone who wants to interrupt and ask any questions, please do go ahead. So there was a few obstacles during the integration. So one thing that kind of we all know probably, but just want to accentuate, there's no solution that fits all. A lot of times we end up with multiple solutions because, especially if you do multiple languages, we considered also like introducing IDE integrations of static analysis. However, again, an integration that might have worked good for the build might not work well for the IDE. Also, vendors will not sell the IDE integration without the build. So it's kind of like a tricky place to be in, because we do want an IDE integration, but then that kind of will force us to get multiple solutions likely at the end of the day. So there will be manual work required. It's not, a lot of times when you talk to the vendors, they will say, oh, it's just like a click and it's all automated. But a lot of times if you use multiple languages, you will have to do some manual work in the whole flow in order to make it all automated later. So yeah, so it's not just a couple of clicks. A lot of times it's creating YAML files, putting into the workflows in GitHub, troubleshooting through them. So definitely allocate time for the static analysis integration. It's not something that's going to go smoothly and quickly, and especially if you have multiple repos with multiple languages, then be ready for troubleshooting, be ready for at least a couple of days of working through it. So once you've done that, let's say you have successfully integrated Sonar Cloud, then what do? You suddenly get like a flash of vulnerabilities, and they are scored by Sonar Cloud or other vendors, but the question is, what are you going to do with them now? So basically you have to understand one thing is vulnerability assessment, but one thing is vulnerability management. Once we find the vulnerabilities, we can't just take away resources from a deployment and say, yeah, just stop producing it and go ahead and fix them. It's a bit trickier. This is where things actually get very tricky. So like if we have a deployment date that's getting quite near, it's very unlikely that we're going to get resources to fix vulnerabilities unless they're highly critical and actually very, very dangerous and exploitable. But this is where we need to come in as experts, and instead of just claiming a vulnerability critical just because Sonar Cloud says so, we will have to like properly triage them. So the question that will arise at some point will be, is it okay to be vulnerable? You know, in the case of this little comic that I put, you know, we might think it might be okay, but then get punished later for that. But sometimes actually it is okay to be vulnerable if we're not, if, you know, the applications one was not facing the internet, if it's very unlikely for it to be exploited, then sometimes we can just say, yes, it's okay. We've done a risk assessment, we are accepting this risk, and we can move on. But it will take some work around it. It's not going to be something that's going to be automated and given it to us. So basically, my conclusion is static analysis is not a tool. It's not a solution. It's merely a tool. And this tool is a helpful tool in our vulnerability lifecycle management. However, in order for this tool to work, we do have to have a vulnerability lifecycle management. Without it, static analysis is pretty useless. So to sum it up, knowing what to do with the findings of it is the biggest leap of them all. Integration is one thing, but once integrated, it's important to know what to do with them. So to conclude, let's keep security as an enabler, not a blocker, and let's not be that guy. As you see in the comics, you know, let's not just demand developers to go ahead and fix stuff. If we, you know, if they're stretched, if they have a lot of things to do, we need to know what's important. And we need to be able to say, not do everything, but just do the important bit, and still, you know, carry on with deployment and production. And that's it for me.
All right, thanks, Petra. So yeah, I agree on what you say. You know, sometimes it's a kind of tricky to implement things, and it could be for certain stages a blocker. So yeah, with that being said, you know, what we have done here is we integrated, you know, our applications, some of our applications, with Sonar Cloud, and this, you know, the upcoming maybe 20 minutes, I'm going to be walking you over how we have done that. But with that being said, you know, it's crucial sometimes to not only focus just on analyzing the code base, because there could be mistakes. However, you know, in the commits and the version control that you're using, and a couple of stuff. For example, there could be, you know, sometimes that developer make a commit and then pass or write an issue that contain a password or key or stuff. So that's why it's also building about the context, about analyzing the application. Sometimes crucial to analyze the version control that's being used, and to understand also the functionalities, the permissions, and that should be, you know, configured. So and this, you know, small diagram right here, we're using, you know, for the sake of this demo, we're using you know, GitHub, and you can see, you know, it's starting from the branch. So right now it's called main branch, so master main branch the same. And we configuring this on the Sonar Cloud. For who doesn't know, Sonar Cloud is like sort of SaaS tool, static application security testing tool. It does require, however, you know, build a new application. You know, say for example, if you're using C, so it's GCC, C#, then it's MS Build, well, mainly .NET, MS Build or .NET. So yeah, so when integrating this with the Sonar Cloud, there's a couple of configuration that has to be made. In our approach, what we have done is basically we created workflow in GitHub, and we trigger, the GitHub Action. It's a nice feature that GitHub has. Besides of creating that workflow, we made the repos over there to communicate back to Sonar Cloud, server, and over there push the code. Now the cool thing right here is that we have GitHub gives you an ability to have a runner running over there. So we use that runner of GitHub to build our projects and then push the code build to the Sonar Cloud, and then configuring and seeing the output in the Sonar Cloud dashboard. So that also adds a bit of flexibility in terms of, say, you've got a couple of branches, developers, submitting codes the entire day, so they create their own branches and stuff. So when this code get to merged, after sorting conflicts or whatsoever, get merged to the main branch. So in this case, we trigger the Sonar Cloud analysis, and over there we added some conditions within the Sonar Cloud dashboard to check if the test cases are passed or not. What I do mean in passed is, say you've got an XSS vulnerability that been detected, so that Sonar Cloud flag it over there for security folks, to look over it and then flag it. And if the test cases, if there's one vulnerability or code smell have been found more than one or two, so we flag it and we block the commit. The cool thing right here is that it's a flexible in terms of integration. You can integrate it, with the Slack, Teams, Jira, whatever system that you're using for communication, and also gives you a bit of notifications. Now, in terms of the integration, why Sonar Cloud and not the others? Mainly, most of the work that we do is open source. So Sonar Cloud gives a bit of flexibility in terms of analyzing the open source, of course, for free. So you can configure it in your repo if it's public, and that way you can merge your work and see the output. If we can go to the next slide, please. Right. So it's a straightforward the configuration, but it's a pain the building. In terms of configuration, what you need to do is you simply, you go into Sonar Cloud dashboard, you create, a project, and then it asks you, as you can see in the right pane, about, what type of project that you created. Is it .NET, C, C++? For this demo, we use C and C#. So you can see you choose the operating system that you're going to be running the code on, either Linux or Windows, and then it gives you a token, and then you copy that token, you place it in your GitHub secret, and that was also one of the best practices. You don't have to hard code SSH keys or tokens within the GitHub YAML file or the workflow file, because that obviously anyone can read it, and then bad things could happen. So yeah, GitHub also gives you a place where you can store these secret, and then you call these secret as environment variables. Then you create the YAML file. So Sonar Cloud takes its configuration out of YAML file, a normal YAML language that you write in, about defining which repo you need to configure, what blockers you want on. Do you want it on the build? Do you want it on the master branch? Do you want it, on a different repo? And then right there, you add your custom build commands, which means, say, if you have, a C application that you use make command to build things, or you use GCC to export some DLLs and then call them in the build. So you need to define this out. And in the execute the Sonar scanner right there, you can find the what you need to copy and paste in your file. So that mainly from the Sonar Cloud side. However, you would need to test it, of course, when running into the configuration. The reason being, right here, you would need to make a lot of test cases, really, because sometimes the developers could submit code that is not valid, or maybe copy on the wrong file, and they get ignore, they didn't state certain stuff. So that's crucial because Sonar Cloud cannot really, detect or do the auto build. It does contain an auto build feature, to build, but for the complex application that requires, DLLs, building other projects or dependencies on other solutions. So that's really really difficult for Sonar Cloud to auto build. I think for most of the tools on the market out there. So that's why it's crucial to build it and test it. And the way that you can do that, basically after configuring it and with a YAML file, you can make a test, edit or commit in your repo, and then it will trigger the action. Then you can see it in the action. We have a POC, so we'll go over that. So all right, next slide, please. Awesome. So this is how the simple YAML file look like. If you see, in line number 1, that you create a name for it. So it's for this one is C#, so CS is C#. It's also good to practice that you specify a useful name when creating your YAML file, because obviously if you're gonna run into multiple projects, say Node.js, C#, C, Python, you would need to create a separate YAML file for these. And if you call your YAML file Sonar Cloud, then you won't know which one is invoking which one. Well, you can know, but it's gonna take a lot of time. All right, so right here you can see, we triggered in 2 environment variables right here: the organization name, which we call it right here for files plus 2, and the project name. The project name should be the same as the project name that you created in the Sonar Cloud dashboard, because these are environment variables. So when you do the build and push the code to Sonar Cloud server, then these environment variables should be matching. And if they don't match, you got a build fail. And we configured it in line 6, on. That means trigger, the build on the branches, and right here we added develop, so that was the branch that we're working on. And then in the jobs we trigger this runner. A runner is like sort of operating system, like Docker, think about it. And then it does the build. However, right here we added something extra in line 12, that you can see there's a glass wall ICAP CS space. So the reason he, we're using C#, and in the project that we used, if you can see in the run command started from line 23, there are more than one projects. Well, basically there are a bit of solution file, and that solution file, the SLN, contains multiple projects, but these projects are C#. So in order to build these and gather their dependencies, so what we've done in the Docker Hub, we created a base image, and that base image contain all the dependencies and stuff. The reason being is to cut out the time, when building the build before pushing it to Sonar Cloud, because it takes some time. So to cut out the time, we've added the a base image that contain all the necessary libraries and DLLs already configured there, and it update itself on every build, so it doesn't take more than 2-3 seconds. And then we're using the Ubuntu lattice as the runner on the GitHub itself to build up our code. So that speeds up a lot. And that's also really recommended, because we faced an issue that if there's multiple developers submitting the same time, it takes a bit of time to build and then to run the checks and then for them to wait to get the result. So that having the base image really solved the problem in terms of also performance. Another thing that if you're using C, say for example, and you got a lot of stuff to build, running say a lot of libraries, glibc, a lot of stuff, updating Ubuntu. So in that case, it's gonna take even more time to build. So it's a best practice to create, just a base image. It keeps updated, just run the patching and the update on it every time it's triggered. But on the other hand, all the libraries is there, so you don't have to wait for building the libraries or calling glibc and stuff. So yeah, and this way, if you see from line number 22 starting, from 23, you see that we invoke in the .NET Sonar scanner, and begin means it's like PL SQL thingy. It's for Sonar Cloud to understand that we are, this is the starter of definition of our build, and here are our, environment variables. So you can see it's in $env Sonar organization, which is defined in line number 3 at the top. We pass in the secret, the Sonar token that we took when we created the project. And this is the way you just say secret, and then you call the secret name, and you'll get GitHub, and that the way you submit it. Right here you add the building command. So in line 25, .NET restore, .NET build, and we got a testing, testing use cases. So we also include in that. And at the end, we end the command in the end. So in line 28, after Sonar scanner, you see end the Sonar login. So that terminates the session. And then you get the environment variable. So basically, this is the way. It's quite simple. And if you're wondering where you can find this file, well, basically, when you create a project, you're gonna get the YAML file. So you don't have to do that much really, unless you have a custom or specific builds. So if we go to the next slide, right, okay, everything has a pros and cons. So in terms of Sonar Cloud, there are a couple of limitations really, and also in other tools. Well, first of all, this is static analysis. It's still, you still require, doing the manual analysis, and the reason being these machines, they run based on rules, and they don't have the human intelligence in terms of looking and mapping the details. So a quick example could be if you got a minified JavaScript file, let's say not minified, a JavaScript file, React file, a React build, communicating with a .NET Core API, and then communicating back into MongoDB. That's a way hard to the machine to understand, regardless the solution that you are using. It's really hard for them to understand the data flow analysis of that. So couple of solutions, they do data flow graph, analysis, but it's mainly about, if you define a variable in a file, in a backend file, and then you call that variable or that class based on certain scopes, so that the way they can detect it, but they have no way whatsoever to detect multiple cases, and that's why you still require the manual code review. However, the limitations, the limitation that we found when we use Sonar Cloud, first of all, the IDE support is not that great, because it's still, I think, into development. Right now we 2020, so it's still in development. And also they don't support all the languages that heavily used, like the C#. So that's doesn't have a full support, and also they don't support all the IDEs. So if you look into IDE, you need to check out based on their documentation, what they support and what they don't. Another thing, if you're gonna be analyzing, say, if you have a repo that contains multiple projects from multiple types, say you've got Node.js and you've got C#, so it's impossible to create one project for these two ladies, because you need separate projects for each one of them. Sonar Cloud can analyze only on the build for the non-interpreted languages, which means PHP, you don't have to build it. Python, you don't have to build it, because they are not interpreted. And for the C#, C++, you would need really to build it. So the way that it works, you add the project, and then you configure that project. And if you got another project, say you are working with C#, but you've got another project, say Node.js, or you write in TypeScript, so you need to create a different project for that, and you trigger both of these projects on the build when someone does the commit. So that's the idea of how you can integrate multiple projects from multiple types. Another thing, in Sonar Cloud, it doesn't have any machine learning. It doesn't have these deep learning analysis and stuff. So it only flags on something called code smells, and of course there's vulnerabilities, but mainly it's code smells, and code smells means like potential bugs within the code base, and then you need to flag it if it is vulnerability or if it's false positive or not. Another limitation, it leaves and takes its sources from the the builder. So if we talk about say C#, so C# language, to map the language, because first you create your code, and that maps into something called AST in computer science, which abstract syntax tree, and that abstract syntax tree represent a tree for the source code in order to run the queries, because you cannot use regular expressions on these, because regular expression is not designed to parse programming languages that the way. You need to use parsers and lexers. So Sonar Cloud use the parsers and lexers, but it lives on the on the Roslyn analyzers, and that's the same analyzer that created in the Visual Studio. So it uses the Roslyn analyzer to analyze the C# code base, and the Roslyn analyzer already gives some static information about if there's a variable missed, not used. You defined it. You need to make read only or something. So it gathers that that output out of that analyzer, and then it put it for you. And it's also gather the stuff from MS Build, and then it's put it in front of you. And on the other hand, it runs some checks, and the checks follows the OWASP top 10, working from the injection attack till the misconfiguration, security misconfiguration. So it doesn't require, however, a huge learning curve, because it's easy to configure. Just create the project and you move along. But yeah, the only thing that we found, is the build. If the build is really complicated, you would need to invest a bit of time in order to configure your build. Since we've got in our workflow, we've got a bit of C project that really has a lot of dependencies and Docker files and other dependencies. So it was a bit difficult to to create a clean build and use the base image and then push the source code. So yeah, it's free for the, as I say, for the public repos. So that's mainly about the limitation. Next slide, please. Right. If you got, say, multiple projects, and that contains different type of programming languages and workflows, and so on. Say if you got C# and Python and C, so the best way is to create, as I say, configure a project and a YAML file for each project. But you need to do an extra step. You would need to take and create, a Sonar properties file on the root of your repo. And where you get this file is basically when you create the project. You can say the build is manual. I want to build this manually. And then Sonar Cloud, in the Sonar Cloud dashboard, within that dashboard, you find the the properties file, and then you include that file in the root of your repo, and that basically it. So that's how it works. You need to create separate projects and also separate properties files. And I believe now the demo in it. Next slide, please.
Yeah.
Okay, I think it is the demo. Oh no, still. Yeah, still not the demo. I just like demo stuff. Right. So the best practices right here, is to, when you start the configuration and you create your project and within the Sonar Cloud, it's really nice. And also in terms of performance, not nice because it's nice, but it's in terms of performance and also security. If you got, as I said, complicated builds like C, and we faced it, it's better to create a base image that contains all the things that requires for UC project. So say if you got, let's say, 12 million line of code of C, and that also contains dependencies for you know, kernel stuff or drivers that you call in, or maybe hardware thingy, or glibc, and you want to get really rid of buffer overflow attacks, and you know, glibc, these libraries that you call like glibc 6. So what you need to do is simply, you know, to update your build or the operating system, and that means the runner. So if you do it on the runner on GitHub and do the build of the C code on GitHub, that will also take a lot of time, because every time, you know, you need to write apt get update something, right? And also you would need to do that because you don't trust the fact that the runners skipped updated on GitHub, right? That's why you would need to build your base image. That's really preferred, and you can really host it, you know, publicly on Docker Hub, and use that image, you know, that container in your build, and you simply just pass in the command. You don't have to install or build or something. You can do that on that image, Ubuntu image, and or Alpine. Alpine is great. And also to make sure that your base image, your Docker base image is secure, there's an open source, you know, tool, Trevi, that you can use in order, you know, to check for that. And normally, if you're using the Alpine last version, Trevi check's already been made. So you invoke the build, you connect to your Docker base image, and then you pass in the command to the GitHub runner, and then the code get pushed to the Sonar Cloud. We've tried this on a couple of the repos that we have, and it took around 15 seconds to get the result. So that's one of the best practices that we came across. And unfortunately, these information, you know, is not written in the community. We simply, you know, went throughout different paths in order to come up with this approach. Next slide, please.
One sec.
Right,
Demo.
so the demo, lovely time. Okay.
I'll stop sharing my screen.
Right.
You can share yours then, Jameel.
Oh, right. Okay. Let me share this video, and then we can walk over. I don't see a share. Okay, now I see it. Right. Can you guys see my screen?
Yes.
Yeah.
Right. So this is you know, 4-minute demo. You can see right there we have the, you know, the workflow files. Basically, when you create the workflow, that directly get created. And right here I have a couple, you know, couple of projects. And this one, for example, for C, that we're using the C, you know, ICAP C base image to do our build, and then we're using the runner as well. And right there, you're gonna find we have right here 3 projects. 2 is written in C, and 1 is written in C#. So that's the idea. Right here, I'm just doing, you know, a quick, just hard coding, you know, a password or a key in order to get detected, and then, you know, push it in order for the runner to start running and the code get pushed. So yeah, okay, I'm committing the changes, and in the actions you can see there's the C#, the C got triggered, and if you click, you know, in the C#, you can find that starting to do the building. And it initializes, you know, the containers. That means on the runner side, it doesn't mean on our container that hosted in Docker Hub. So yeah, that's from GitHub mainly, that the timing. And now you can see it's instantly jumped into scanning our C# code, you know, and restoring these libraries out of the image, the base image that we already have. And that does basically an auto build. So a developer doesn't have to really think about, you know, building his stuff or not. Let me move that. Okay. And right here you can find that the project that we are analyzing. This is the C#, C#. And you can see also, we created a separate project for each of them. So it took, right here 1 minute, but calculating the time of the GitHub runner, so it took basically 30 seconds. And that's quite, a good number in terms of performance. If you got to use other tools like checkmarks and stuff, so quite understand this is, a good timing. And right here, you can see that, the code spells where you need to flag it, the stuff that get cached from the build side. And if someone gonna be doing, a pull request in order, to merge his code or something, based on his pull request, the Sonar Cloud can analyze that pull request and then give you sort of a score that this is failed because you've got, 2 bugs right there. Go and fix them, and then, try again. So that basically what it does. It could be annoying sometimes for developers, but it's up to you. It's not mandatory to configure it. And this is how the workflow look like, like the one that I shared. Right here you can see, we are not really doing any kind of C commands. It's mainly about using the wrapper that's built on Linux, and that Linux system means our container, which has all the dependencies needed in order to build a project. But normally, when we try to really build the C project, normally it takes more than 7 minutes in order to do the analysis. That adds a bit of speed if you're quite in a hurry. And right here you can see, also within the dashboard what is failed, what's passed, and it's up to you to configure, the conditions. If you click on the add conditions right here, you can filter what kind of condition that you would need to define your pipeline. And for us, we can say if it's greater than 1 bug, then that means the build failed. You can decide if it's vulnerability. You can decide it about the build thing, or the way that you really want it. So that's basically from the demo side, and also you can find a bit of information on the Sonar Cloud documentation website. That's basically it. Any questions?
Thank you. Great presentation. Please, everyone, prepare the questions if you have. I have one question actually, but I don't. I'm not technical person, but just I faced to one project that when customer wants to have Docker built locally, and but we have everything in Java. So I am thinking if you were talking only about C, C# or these languages, when you have libraries in Java, and yes, some REST APIs, will this Docker building work?
Yeah, of course. Well, you've got 2 things right here. You got SCA, software composition analysis, which mainly for analyzing libraries. We're using that something other than really, Sonar Cloud. We're using something also open source, and the OS community created it. Basically, it's called dependency check. So what it does, if you got libraries or jar files that been made in Java, it can basically analyze them and go to a place called NVD, National Vulnerability Disclosure, and matches these libraries with their version, what kind of vulnerability that they have. If there's any REST APIs that you have also on the project, that depends on the language. If they code it in Java, also you can analyze them with Sonar Cloud, of course. But I think it's much more easier than C.
But it is all. And what about first phase, just building it? Then
Yeah, the building the Java, it depends on your build, instructions. For example, if you have certain parameters you pass as arguments to your file, and depends if it's a web file, a web project or an executable. So it depends on how you build this configured. But mainly it's straightforward. So you can just copy your build command, add them into the GitHub Actions, and trigger Sonar Cloud. So in terms of creating a project and adding your custom build command, that doesn't take more than 5 minutes.
Thank you. Thank you. I will share with the developer and if he finds answers there. Thank you. Great. So any other questions? If not, then Petra, you are smiling. You have questions or?
No, I don't have any questions. I just wanted to say also in regards to the Java question, like Sonar Cloud has also, like, if it's Java is the only language, Sonar Cloud does offer capabilities of just automatically setting up the static analysis. So you can, like, if you go through, when you do a project in Sonar Cloud, you can set it out automatically. You pick your open source repo and Sonar Cloud will generate a project automatically without you having to create a specific workflow file. But in that case, that's related to specific languages like not C and C#, but like mainly Java, JavaScript, TypeScript, those kind of languages. You can use the automatic, if that's the only language in the repo, you can use it that way. That tends to be easier. Yeah, correct me if I'm wrong, Jameel.
You're absolutely right, man.
Yeah.
You're always right.
No. But yeah, cool. That's pretty much it. Thank you very much, Jameel, for this cool demo. Yeah, if anyone else doesn't have any questions, we can pretty much wrap it up.
So yes, thank you everyone, and looking forward for our other sessions in Open Security Summit. Please tweet us, follow us, and join our Slack channel if you are not in yet. Thank you everyone, and have a great rest of the day. Thank you.
Cheers.
Thank you.
Bye.
Cheers.